Right now, 70 kilometers from a city of over 20 million people, a volcano the Aztecs named Smoking Mountain is doing exactly what its name promised, and it has not stopped for over 2 decades. Popocatepetl, the second highest peak in North America, has been continuously active since January of 2005. And as of this month, Mexico's National Center for Disaster Prevention still has it sitting at yellow alert, phase 2, the same alert level it has held through years of near-daily gas, ash, and vapor emissions. Just this month, ash plumes rose to an estimated 24,000 feet, forcing aviation authorities to issue repeated warnings to any aircraft operating anywhere near central Mexico. Today, we are going to break down exactly why this volcano refuses to fully quiet down, what the alert system actually means for the millions of people living in its shadow, and what the real, long-term danger from this mountain actually is. No exaggeration, no doomsday guessing, just the monitoring data, the geology, and the real stakes. Drop a comment right now. Have you ever lived near a volcano that just never seems to fully sleep? Or watched one from a distance and wondered how people learned to live so close to it? Tell me where you were. So many of you write in from Mexico and across Latin America, and I read every single one of those comments. If you want to know the moment anything changes at Popocatepetl, subscribe right now. It costs nothing. And a thumbs up tells the algorithm to put this in front of people who genuinely need to see it. Let us get into it. Popocatepetl rises just 70 kilometers southeast of Mexico City. A glacier-capped stratovolcano whose name in the Aztec language literally translates to smoking mountain, a description that has apparently held true for longer than anyone has been keeping written records. Eruptions at this volcano are documented in Aztec codices centuries old, and its geological history includes at least 3 major Plinian eruptions since the middle of the Holocene period, the most recent occurring roughly 1,200 years ago, events that produced pyroclastic flows and massive lahars sweeping down the river basins below the mountain. The current eruptive period began in January of 2005 and has genuinely never fully stopped since, cycling through repeated episodes of lava dome growth inside the summit crater, followed by the partial destruction of that same dome, a pattern that has now repeated for more than 20 consecutive years. This is the key detail that separates Popocatepetl from a volcano like Mayon in the Philippines or Semeru in Indonesia, both of which produce dramatic, discrete eruptive events. Popocatepetl instead behaves like a mountain with a low, constant fever that occasionally spikes, rather than one that goes fully dormant and then explodes. Mexico's National Center for Disaster Prevention, known as CENAPRED, working alongside scientists from the National Autonomous University of Mexico, currently maintains the volcano at yellow alert, phase 2, which sits at level 4 on a 7-level scale, ranging from green through yellow and up to red. That classification has remained essentially unchanged through daily bulletins stretching across this entire year, each one describing some combination of gas, water vapor, and ash emissions, exactly the kind of steady, low-level activity that defines this volcano's entire 20-year eruptive cycle. In recent months, that steady baseline has meant hundreds of individual gas and ash emission events recorded nearly every single day, alongside volcano-tectonic earthquakes and periods of elevated tremor that seismologists watch closely, because shifts in tremor frequency and duration often precede the more explosive episodes, hiding within this otherwise routine pattern. This month, ash plumes from the summit crater have repeatedly risen to an estimated 24,000 feet above sea level, prompting the Washington Volcanic Ash Advisory Center to issue formal warnings to pilots, since ash at that altitude poses a genuine hazard to jet engines operating anywhere in the surrounding airspace. Volcanic ash is not simply dust. It is composed of microscopic fragments of glass and pulverized rock that melt inside a jet engine's combustion chamber at cruising temperature, then resolidify on cooler internal surfaces further back in the engine, a failure mode that has caused multiple commercial aircraft to lose engine power entirely after inadvertently flying through ash clouds in past decades elsewhere in the world. These advisories track the ash plume's exact drift direction hour by hour, because unlike a ground-based hazard, an ash cloud at cruising altitude can affect flights hundreds of kilometers from the volcano itself, well outside anything resembling a conventional danger zone, which is exactly why Mexico City's own international airport maintains standing coordination protocols with CENAPRED specifically built around this volcano's ash output. Here's the number that actually matters most about this entire situation. And it is not a magnitude or an alert color, it is the population figure. More than 20 million people live within a wider metropolitan region surrounding this volcano, including all of Mexico City, and roughly 30 million people live within a 70-kilometer radius of the summit, according to NASA Earth Observatory analysis, making Popocatepetl one of the most closely watched volcanoes on the entire planet purely because of who lives near it. A permanent 12-kilometer exclusion zone surrounds the crater, strictly enforced and impossible for the general public to cross, and the communities living just outside that ring have built their entire relationship with the mountain around one unavoidable fact. this volcano has not gone fully quiet in 20 years, and nothing in the current data suggests that is about to change. What almost nobody outside volcanology fully appreciates is that the actual long-term danger from Popocatepetl is not primarily the ash falling on Mexico City. Inconvenient and disruptive as that regularly is, it is the lahars. A lahar is a volcanic mudflow created when eruption debris, loose ash, and pyroclastic material mix with rainfall or melting glacier ice from the volcano's summit and race down river valleys with roughly the consistency of wet concrete, capable of burying entire towns built on ground that looked perfectly solid decades earlier. Popocatepetl still carries glacial ice near its summit, and the combination of that ice, the mountain's steep upper slopes, and Mexico's seasonal heavy rains creates exactly the conditions volcanologists point to when they explain why this specific hazard, rather than a dramatic explosive eruption, represents the greater long-term risk to the communities living in the surrounding valleys. Historical eruptions at this volcano have already demonstrated this exact mechanism, with lahars from past eruptive cycles reaching river basins well beyond the boundaries of any exclusion zone drawn around the summit itself. What makes this hazard particularly deceptive is timing. A lahar does not require fresh eruptive activity to occur at all. Ash and loose volcanic debris deposited months or even years earlier can sit quietly on the upper slopes until a single intense rainstorm finally mobilizes it, meaning the most dangerous moment for a downstream community is not necessarily during an eruption itself, but potentially during an entirely ordinary rainy season afterward, when public attention has already moved elsewhere. So why, after 20 years of essentially continuous activity, has this volcano not escalated into anything resembling a major catastrophic eruption? The honest scientific answer lies in the actual physics of what is happening inside the mountain. Popocatepetl's current eruptive style is dominated by what volcanologists call dome building and destruction, magma rising slowly enough to form a solid plug inside the summit crater rather than erupting as free-flowing, rapidly ascending material. That dome periodically grows, becomes structurally unstable under its own weight and internal gas pressure, and then partially collapses or is blasted apart in a moderate explosive event. Venting pressure before it can accumulate to genuinely catastrophic levels. This is fundamentally a pressure release valve, operating on a near continuous basis, rather than a sealed system building toward a single massive rupture. And it is exactly the kind of behavior that explains why a volcano can remain active for 2 straight decades without producing anything close to the Plinian eruptions recorded in its own geological past. Compare this to a volcano like Mount St. Helens in 1980, where a bulging flank sealed pressure inside the mountain for months before finally failing catastrophically all at once. Popocatepetl's dome simply cannot seal pressure that way for long. Its structure is inherently unstable at a much smaller scale, which means it fails early and often instead of rarely and enormously, a genuinely different eruptive personality that happens to be far safer for the millions of people living nearby, even though it produces far more frequent headlines about ash and gas emissions. CENAPRED's monitoring network reflects just how seriously this steady-state hazard is still taken, despite its familiarity. Continuous seismic stations tracking every tremor and volcano tectonic earthquake, thermal cameras watching the crater for signs of new dome growth, gas monitoring equipment sampling sulfur dioxide and other volcanic gases, and a dedicated webcam network streaming live visual conditions around the clock. All of it feeding into daily public bulletins that have not missed a single day through years of sustained activity. If you live anywhere in the wider region surrounding Popocatepetl, here is what is actually worth understanding right now. Respect the 12-kilometer exclusion zone completely, since it exists specifically because of this volcano's well-documented history of sudden dome collapse events and explosive ash emissions that can occur with very little additional warning beyond the daily baseline activity. If you live along any river valley draining the volcano's upper slopes, take heavy rainfall seasons seriously as a lahar risk independent of whatever the current alert level happens to be, since a lahar does not require a dramatic new eruption to occur, only loose material already sitting on the slopes and enough water to move it downhill. Keep a dust mask or respirator on hand if you live anywhere within the regular ashfall zone, since ash from this volcano has disrupted daily life in surrounding communities repeatedly over the past 20 years, and know that regional aviation authorities monitor and reroute flights, specifically because of exactly the kind of ash plume activity recorded again this month. Final thought. Popocatepetl is not a volcano building towards some inevitable future catastrophe, and it is not a dormant mountain that suddenly woke up either. It is a system that has found a sustained equilibrium, venting pressure, through repeated dome growth and partial collapse cycles for more than 2 decades running, sitting directly beside one of the largest metropolitan populations on the planet the entire time. The real lesson this mountain teaches is not about explosive risk. It is about what it looks like when a genuinely active volcanic system and a genuinely enormous human population learn to coexist through nothing more dramatic than daily monitoring, a respected exclusion zone, and a public that has simply adjusted its expectations to include ash advisories as a routine part of regional life. We will keep tracking every CENAPRED bulletin, every ash advisory, and every shift in this volcano's alert level as it happens. Subscribe so you do not miss it, and leave that comment below. Have you ever lived near a volcano that never seemed to fully stop smoking, or is Popocatepetl the first mountain like this you have ever heard about? Because for the tens of millions of people living in its shadow, this is not breaking news. It is simply the mountain they have always lived beside. Let us get this one to 5,000 likes. See you in the next one.